All right. So, as we talked about the other day, back before, obviously, y'all went on the San Antonio trip, we talked about square roots, and we talked about perfect squares. So, for example, we talked about the square root of 49. The square root of 49 is what, Tayshawn? 7. Now, remember that it also is positive or negative 7, okay? If they ask for the two square roots like we did. Obviously, you had a test on Wednesday before you went on the San Antonio trip. We had all the square root signs, stuff like that on it. That test is on RenWeb. I've already got it on there. It's been recorded. Now, what we're going to talk about today is we're going to talk about, instead of perfect squares that we talked about in 11.1, today we're going to talk about what we would call irrational square roots. Okay? Now, an irrational square root is a square root that's not a perfect square. Okay? So, for example, we know that the square root of 4 is what, Jesse? 2. Okay? Do we know what the square root of 5 is? Huh? No. It's not a perfect square, but there is a square root for it. Okay? There is an approximation of the square root. So, for example, the square root of 5 falls between the square root of 4, which is 2, and the square root of 9, which is 3. It falls in between those two. So, that means that the square root of 5 has to fall between 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, or 2.9. Okay? Now, it's going to fall between, it's going to be the approximate one of those numbers right there. Now, how do we eliminate some of those numbers? I don't want to have to sit there and go 2.1 times 2.1, 2.2 times 2.2, 2. Okay, you don't want to do that. Okay, it would take a long time even if you had a calculator. Okay, so what we've got to do is that we've got to decide this. Does the square root of 5, is that closer to the square root of 4 or closer to the square root of 9? Is it closer to 4 or 9? 4. Okay, so it's going to be at this end of our numbers, okay? Because 2.1 times 2.1 is going to be closer to 4 than 2.8 times 2.8. Okay, 2.8 times 2.8 is going to be down there by 9. Okay? So, what we're going to do then is I'm going to take and I'm going to multiply 2.2 times 2.2. I'm going to choose the number that's right in between those three. And I'm going to see what it equals, okay? So that would be 4, 4, bring down a 0. That would be 4, 4. So that's 4, 8, 4. And I've got 2 decimal places. So that's 4.84. Well, 4.84 is pretty close to 5, okay? But could 2.3 be closer? Well, let's see. 2.3 times 2.3. And this is just the part you have to do. It's just experimenting with the numbers that it could possibly be. 2.3 is 9, 6, bring down my 0, 6, 4. That would be 9, 2, carry my 1. So that's 5.26. Oh, 2.9, thank you. Thank you. That's good because we would have had an issue if it would have been that. Okay? So, now what we have to decide is which is closer, 5.84 or 5.29 to 5? 4.84, I think I said 5. 4.84 is closer because it's 0.26 away from 5. 5.29 is 0.29 away from 5. So the closer one is 4.84. So that means that my square root of 5 is approximated to 2.2. And that's your answer. Are we going to do different numbers than what? Oh, yeah. Yeah. Yeah, there's only 1 5, so that means you'd only have one problem if we just did 5. Isaiah, do you have a question, or are you trying to hit Gabby in the face? I'm confused at what you just said. No, this right here, I was just saying that this number falls in between this and this number. Those are perfect squares. So this is a perfect square, that's a perfect square. This is not a perfect square, but it falls in between the two. And so that means that since the square root of 4 is 2 and the square root of 9 is 3, that means my number has to be one of these numbers right here. Now, if you actually approximate it, let's look at the actual approximation of the square root of 5. There it is. Yes. It's an irrational square root. So what an irrational is an irrational number is a number that continues to go on forever and doesn't repeat the same block of digits or the same digits in the same order. Okay? Then it wouldn't be an irrational square root. You're not going to have a square root in other words, you're not going to have a square root that's 1.3 with a bar over the 3. You're not going to have that. That's impossible. Okay? Now, this one here, obviously, there's a 6 and another 6, and there's another 6 and another 6. But the problem is they're not in the same spots. In other words, 2.23606. Okay, well, maybe it's repeating that block of digits. No, then it goes 797749. So it would go on forever. If I had enough room on my screen, on the tablet, it would go on forever. Okay? So they are saying that the 2.2, they're saying this then. The square root of 5 is approximately, and they do the little S equal sign, 2.2. Okay? That means it's approximate, because there is not a perfect square, so it's an irrational number because it continues to go on forever. So these are irrational square roots that we're going to be dealing with today. Okay? Some of them will be whole numbers and perfect squares, but most of them will not be. Now, let's look at this one. Let's say I had the square root of 125. It's funny, I just did this in 8th grade, just last hour. You put the square root of 5, and then you're going to have all that work that I showed underneath it, and then you're going to circle 2.2. Okay? Now, let's say I had the square root of 125. Well, this one's a little bit more difficult because I have 3 numbers. I have 125, so just 5. So I have to figure out where the square root of 125 falls between. Okay? Well, it's not a perfect square, but it falls between the square root of 121, which is 11, and it falls between the square root of 144, which is 12. So that means that the answer then has to be 11.1, 11.2, 11.3, 11.4, 11.5, 11.6, 11.7, 11.8, or 11.9. Has to be one of those answers. Now, once again, we look at the number, 125. So is 125 closer to 121 or 144? 121. So we can take and mark out those numbers. It can't be those numbers, because all those numbers, the more you multiply here, the closer you're going to get to 144, and 125 is only 4 away from 121. Okay? And it's like, what would that be? 19 away from 144. Okay? So it's got to be down here at this other end. So once again, we're looking at these three numbers. Well, I just always pick the one in the middle and try it. So 11.2 times 11.2. That would be 4, 2, and 2. Bring down a 0. That would be 2, 1, 1. Bring down 2 zeros. That would be 2, 1, 1. That would be 4, 4, 5, 2, 1. I move it 2 places, be right there. So it'd be 125.44. And I'm looking for what? 125, right? Okay, well that's pretty close, but I've got to check, it's already over, so I got to check 11.1 times 11.1 to make sure that it's not closer. You can be over. In other words, this is not wrong because it was over. Okay? It's whatever is closest to the 125. And this is, I can't remember if that one's it or not. But Brandon, do you have a question?
Under 224, how did you get 1,120?
Okay. Bring down a 0. 1 times 2 is 2. 1 times 1 is 1. 1 times 1 is 1. Okay? Quaid? This one is 4.84 because 2.2 times 2.2 is 4.84. But now, when you get to 2, you get 2 times 3 times 2.3 times 2.3. Okay? Well, we know that 2.5 times 2 is 5. So 2.3 and another 2.3 is going to have to be over 5. That's why it's 5.29. Okay? Now, back up here. Yes, sir? Mm-hmm. That's what it has to be, since I'm approximating to the nearest tenth. That's what numbers are between 11 and 12.
Yeah, I mean, how do you know which numbers to stop at or which numbers to go to?
How I got these numbers right here, okay, how I decided to use those numbers is because 125 is closer to 121 than it is 149. So this number right here, 144. This number right here is going to be real close to 144 when I multiply it out. Let me show you. Who'd she say? 11.9 times 11.9 is 144 or 141. Okay. Huh? Well, all I'm doing there is I'm estimating where I think the answer is going to be. That's all it is. I'm just taking a guess of where the answer is. So let's say this, Isaiah. Let's say it was the square root of 135. Okay? The square root of 135 is exactly right in the middle of 121 and 144, or almost. So what I would do then is I would come right in the middle and start trying those three numbers right in the middle. Okay? Let's say it was 142. If it was the square root of 142, then I'm going to come down here at this end and try these three numbers, because 142 is real close to 144. And so I'm just sort of taking bits, and I'm taking three numbers here, here, and here, depending on where my actual number is located compared to the other two numbers. Okay? All right. All right, now 11.1 times 11.1, that would be 1, 1, 1, bring down a 0, 1, 1, 1, bring down 2 zeros, 1, 1, 1. That would be 1, 2, 3, 2, 1. 123.21. Now, is that or 125 closer, 125.44 closer to 125? Yeah, 125.44. So that means 11.2. The square root of 125 is 11.2, approximated to the nearest tenth. Okay? Okay? Now, let's look at this one. Square root of 253. Okay, the square root of 253. Think you could have got another color in there somewhere today? Have your orange and red and green and black and blue and gray. There's not going to be much match those shoes because they pop out there. Oh, I know you do. I've seen it. I was blinded one day by it. All right, so square root of 253. Okay, first of all, we got to figure out that the square root of 253 falls between which two perfect squares? Which two perfect squares does 253 fall between? 15 and, so 225, so 256. So the square root of 225 is 15. So we know ours is larger than 15. The square root of 256 is 16. So it falls in between both of those. Well, the numbers that are in between those are these. Now, 253, is 253 closer to 225 or 256? 256. So that's 256 is up here by 16. So that means that my estimate is probably going to be closer to 15.8, 15.9. Because 253 is real close to 256. So if they're real close, then that means the square root of 253 has to be real close to 256. These are the two numbers that are going to be closest to 256 because we know it's 16. So the square root of 256 is 16. So that means that the square root of 253 is very close to 16. In other words, is it going to be 15.1? No, 15.1 times 15.1 is going to be like 227. That's way down here. Okay? Well, 15.5 times 15.5 is probably going to be somewhere in the neighborhood of 242 because it's right in the middle. Okay? So I'm closer to this end, so I want to start my experimenting at the far end of the numbers. Okay? Isaiah? Okay? All right. 15.8, so I'm going to start with it first. I'm going to take 15.8 times 15.8. Okay? 8 times 8 is 4. Carry my 6. 8 times 5 is 40, plus 6 to be 6. Carry my 4. 8 times 1 is 8 plus 4 would be 12. Bring down a 0. 5 times 8 is 0. Carry my 4. 9, carry my 2. 5 times 1 is 5 plus 2 would be 7. Bring down 2 zeros. That would be 8, 5, 1. That would be 4, 6. 2 plus 9 is 11. Plus 8 would be 19. Carry my 1. 1 plus 1 is 2. Plus 7 would be 9. Plus 5 would be 14. Carry my 1. 249.64. What was my number? 253. So that's not close. So I got to try 15.9 times 15.9. Okay, for simplistic sakes, oops, that was wrong. $252.81. Okay, 252.81. Well, is that close to 253? Yeah. Yeah, it is. So, the square root of 253 is approximately 15.9. Because we know that 16 times 16 is 256. So obviously 252.81 is going to be closer to 253 than 256 is. Okay? Isaiah? No, if you put 15.9 at the bottom of your work, that's fine, as long as you circle it. Okay? Now, let's talk about irrational and rational square roots. The square root of 84. The square root of 84 is irrational. The square root of 84 is irrational because it is not a perfect square. Because there is no square root of 84, you'd have to approximate it. That's 64. Okay? So this is irrational. So the square root of 81 is rational. The reason it's rational because there is a perfect square. Now, but the other numbers they're going to look at here okay, irrational numbers are those numbers that never end. They're infinite. Okay? So when you see 5.653789, okay, and you have 3 dots after it, this is irrational. If you had this would be rational. The reason it's rational is because I can express that number as a fraction. Okay, 5.6 with a bar over it is 5 2/3. If you can express the number as a fraction, or the answer as a fraction, then it's a rational number. So, 7/9, that's rational. Square root of 22, irrational. 5, rational. Square root of 36, rational. Okay. Do what? Which one? Why, square root of 22 is irrational? Why it's irrational? Because it's not a perfect square. It has the answer to the square root of 22 is a number that keeps going and going and never stops. Yeah, like here. You say 22 square root. Whoops, hang on. It just keeps going. Now, if I had 7 over 9, that's 7 divided by 9. Okay, now, that's rational because what is it doing? What number is it repeating? 7. So a repeating decimal number, and it's got an 8 at the end because it's got to stop because there's no more room on the screen. Okay, that's why it's got an 8 at the end. Okay, but that's rational. It's still rational because it's a repeating decimal number. It has an end. Its end, 7 over 9, is just 0.7 with the bar over it. That ends. Okay? It's irrational if it's an infinite number that infinite numbers do not repeat. They keep going on forever, but they don't repeat numbers, and they don't repeat block of numbers in the same spots. Irrational number would be any square root that doesn't have a perfect square, and any number that looks like this, that has the 3 dots at the end. If it has the 3 dots at the end, or if it's not a perfect square, then it's an irrational number. Okay? If it is a, listen to me, if it is a whole number, if it is a fraction, if it's a decimal that ends, if it's a repeating decimal, or if it's a perfect square, then it is a rational number. Okay? Whole numbers, fractions, decimals, terminating or repeating. Okay? Those are all rational numbers because they can be written. Bottom line is what makes a number rational and what makes a number irrational is a rational number can be written as a fraction. How do you write 5 as a fraction? 5 over 1. Okay? That's why it's a rational number. How do we take and write the square root of 22 as a fraction? You can't because the decimal number never ends. Because with a repeating, here's why a repeating decimal is rational. 0.3 with the bar over it. 0.3 with the bar over it can be written as a fraction. That's 1/3. So I can write that number. But a number that never does end, just keeps going, how would you ever know, okay, what place value do I put it over? Okay, for example, square root of 2. Let me clear that. Okay, so what place value would I start my fraction on? Tens, hundreds, thousands, 10,000s, 100,000s? Well, we don't know because it never ends. So there's no way to make it a fraction because it never ends. It just stops out there. So what they've done here is they've done the same thing that we did a while ago when you get 1 divided by 3. Let me do another one because that one obviously not going to be rounded. They rounded it. So for all we know, that 7 right there is rounded. It obviously is. It's either rounded at the same or it rounded up. Okay? So that's the difference between the two. All right, your homework for tonight. $11.2, 2 through 9, 15 through 18, and 23 through 30. Now, everybody look at number 2. The directions tell you to approximate the square root to the nearest whole number and then to the nearest tenth. All you have to do is round it to the nearest tenth. You don't have to do the whole number. Okay? No, just approximate it to the nearest tenth, just like we were doing in class. You don't have to put 2 different answers. You're just going to put, 2.8 or whatever the answer is. Okay? All right, you still got 10 minutes left in class. I need you working on this. So go ahead and get started on it.